CSEC Mathematics, May 2025. We're at question 9. It says a ship sails from point A to point B, which is 15 kilometers from A on a bearing of 42 degrees. And of course, it says 042 because you use 3 digits when you're dealing with bearings. The ship then sails to point C, which is 19 kilometers from B on a bearing of 130 degrees. The following diagram shows a sketch of the ship's journey. On the diagram, insert the bearings 42 degrees and 130 degrees. Alright, so let's copy this diagram and paste it over here. Alright. Now, 42 and 130. Well, the 42, 042 would be here. Right, the degrees, but I don't want to crowd the diagram too much. Now, remember, bearings are measured from the north in a clockwise direction. So the 130 would be here. Alright? 130 degrees. The distance between town A and town C, it says it leaves town A going, well, let's write the B and the C as well. So this is town B, this is C. It says to be 15 kilometers. So you have 15 kilometers here. To point C, which is 19 kilometers from B. So 19 kilometers from B. So this would be 19 kilometers. All right. So you have the calculate the distance between town A and town C. A and C. All right. We want the distance from town A to town C. Now let us make a copy of this diagram and work on that. Now remember, this here is 42 degrees and this is 130. Alright, let's concentrate on the 42 here. What happened? We need to know this angle, because you see, if we have this angle, you see, like this 15 kilometer and this 19 kilometer, we could use the cosine rule. This is C here, and say AC squared. And remember, the cosine rule is on the formula sheet, right? AC squared is equal to, B would be here, equal AB squared plus BC squared minus 2 times AB times AC cos that angle, right? Whatever that angle is, we need to figure out what it is. Now, suppose we should extend this line. Then this would also be 42. See that? Because remember, this is not, this is not. This is the same line extended, so that would be 42. But then we have the whole angle here from the north line all the way around is 130. So if we take 42 from off 130, 130 minus 42, let's just use a calculator this time. 130 minus 42 gives us 88. So this angle is 88. So this is 88 right here. But remember now, going straight along this line is 180 degrees. So this angle in here call it angle ABC. ABC would be 180 minus 88. Right? See that? So therefore 180 minus that is equal to 92 degrees. So this angle is 92 degrees. Alright, so we can work with it now. This is cos 92. So, and what they say again, the distance, calculate the distance from town A to town C, right, which is AC. So in this case, AC squared, whatever it is equal to AB squared, which is 15 squared plus BC squared, which is 19 squared minus 2 times 15 times 19 cos 92. When you work that out now, 15 squared plus 19 squared, so we have 15 squared which is 225, and 19 to the power of 2 is 361. So it's 225 plus 361. 225 plus 361 minus 2 by 15 by 19. 15 2 is 30. 30 by 19 gives us 570. 570 times cos 92. Alright, so let's work this out now. 225 plus 361 equal is 586 minus 570 times cos 92 and cos 92 equal, I have what, 605.89. Alright, 605.89. Let me write this 5 properly. 605.89. This would be kilometer squared, because what we have is AC squared. We need AC. So AC is the square root of 605.89, which is, so the square root of that is 24.61 kilometers. 24.61 kilometers. All right. So you see that. Now, what else let's say happen? So that's 2 marks. Determine the bearing of town A from town C. 3 marks. Wow. The bearing of A from C. Alright. When you say from C, it means C is where you're going to draw the, well, you have the north line and then the arc. So this angle is what you want, alright? You want that angle. No. The thing is, mosquito. Yeah. The thing is this now. You have, which angle you have now? This angle. And this. If you should extend this line here, right? You have the same 130 degrees right here. 130 degrees, right? That's what you would have. Now, that's 130 so far. Now, what else have we got here? The bearing. They ask for the bearing here of town A from town C. So we need this angle. Now, let us see if we can find this angle here. If we find it, that would be good. Because what we could do here, let me see, we have 130 here. This going all the way around from here would be 180. So we could minus that to get what we have left here. And what we have left here, we add to 130, right? So let's see if we can find this green angle here. We know that this is 24.61 kilometers. So this is 24.61 kilometers. These are in kilometers. Can we use the sine rule to do it? Let's say the sine rule is also in your formula sheet. 24.61 over sine 92. 24.61 over sine 92. And by the way, let me just copy the question. Just copy the question here. And paste it. Let's drag this question down here. Right, to show that that is what we are calculating. All right. So 24.61 over sine 92 equals 15 over sine ACB. So that's equal to 15 over sine ACB. Alright, so if you transpose this, we get sine ACB equals 15 sine 92. Alright, so 15 times sine 92 over 24.61 equals what? That's 15 times sine 92 equal over 24.61 equal 0.609. So this is 0.609. So ACB, the angle ACB is equal to sine inverse of 0.609. So we want to find the sine inverse of that. In this, that's what they call arc sine, a sine, inverse sine. So that's what I have on my calculator. Inverse sine of that equal 37.53. So we have 37.53 there, right? So that's what we have there, 37.53. All right. Now, BA here now. This is 37.53. Now here, all of this is 180, you know. So if we drop 37.53 from 180, this angle will be 180 minus 37.53 equals what? $180 minus that equal 142.47. 142.47. That's 142.47. So that 142.47 is this angle, right? So what we do is add 130 to it. So the bearing equals 130 plus 142 point, what was it again? 47. Remember though, you know, in exam you would write out these things line by line. You wouldn't just put it up here. This calculation, you would put it on a line here, and you would say, you could put, you have ABC already, put D, and say ACD, right? You could put D here, and say ACD, angle ACD equal, and you write it separately. All right, degrees. Now, when you add these, what do you get? So you have 130 plus 142.57. 130 plus this equal 272.47. Equal 272.47 degrees. That's the bearing, right? So that's the bearing. That's 3 marks. All right. What the, something else now. Circle theorem. Something about circle theorem here. Right, let's look at this. Let's erase the board. we're going to copy. And before we copy it, it says the point L, M, and P lie on the circumference of a circle whose center is O. The line NP is tangent to the circle at P and angle, and OMN, the line OMN is a straight line. The line PL is a diameter and angle ONP equals 24 degrees. Okay, you can see all of that here. Alright, let's copy and paste the diagram from now. Now, calculate the value of each of the following angles, showing detailed working where necessary, and give a reason to support your answers. Angle PON. Alright. Paste. Angle PON. So angle PON is the angle that you want here. Alright. So let's see how this goes. PON. This angle they want you to find. Right? Now, consider this triangle here. Alright? What would this angle be here? It's 90 degrees because, and you would write it down, write down everything. You say in triangle PON, angle OPN is a right angle because it is the angle between the diameter and the tangent to the circle, where the diameter meets the tangent at P. Alright? So it's not an assumption, you know exactly what you're talking about and you show it. Alright. Now the total angle in the triangle is 180. So you could say here that PON is equal. Alright, so you put it this way, PON plus 90 plus 24 equals 180. So PON, could put this for angle PON equal 180 minus 90 minus 24 equals 90 minus 24. That's what, 66. Well, 180 minus 90 is 90. 90 minus 24 is 66 degrees. So what you have here is really 66 degrees, right? All right, that's what you have there. What else is going on? Angle PLM. PLM. You want angle PLM now. Let's erase what we have here. And we have PON equals 66. And go back to that later on. Now, angle PLM. Where's PLM? PLM. Okay. PLM is this angle. This is the angle I want. Alright? Now, let's look at this. PLM. Suppose you consider, first of all, we might make use of the 66, so Let's put back the 66 here. But suppose you consider this triangle. Triangle LOM. Alright? You have OM equal OL. And remember, you write down everything. You say consider triangle OM equal OM because OLM is isosceles. It is because, guess what? From O to L is a radius of the circle. From O to M is the radius of the same circle. So they must be equal. So OL equal OM. So OL equal OM. Alright. What does that mean? It means angle OLM. Therefore, angle OLM equal angle OML. Call them X equal X, whatever X is. Alright? Now, look carefully at this thing. Alright? What you can do is to say, looking at it, so this angle and this angle will be the same, right? And they ask you for PLM. Okay. Now look at this. This angle is 66, alright? Now this angle would be what? Remember, going right around will be 180. Alright? So angle LOM is 180 minus 66. Angle LOM is 180 minus 66 equals, what is 180 minus 66? 180 minus 66 equals 114. Equals 114 degrees. Alright? So this angle here is 114 degrees. Okay? Now, look at this. You see the angle OLM equal OML equal X. You call this X and call this X. The fact is 114 plus X equals 180 in this triangle, right? 114 plus X equals 180 because all three angles add up to 180. X plus X is 2X, so we say 2X equals 180 minus 114. So we have 180 minus 114. 180 minus that is 66. 66 degrees. So divide both sides by 2, you get X equals 66 over 2, which is 33 degrees. So what we call X is really 33 degrees. So OL, what is it? PLM is 66 degrees. Alright? It's 33 degrees. So what you have is that PLM is equal to 33 degrees. Alright. See that? That's angle PLM. Now, That's 2 marks. This is one for 2 marks. Angle PMN. No. PMN. PMN. Alright. Now PMN is going to be this angle. What is it? Let's see what's going on here now. Guess what? You notice here you have a diameter and you have this angle lying on the diameter. From your knowledge of circle theorem, what does that tell you about this angle? Angle PML. What is angle PML? Oh, by the way, let me copy this thing. And paste it over here. Let me just copy it from now. Alright. So, here, we're saying this angle here. Oh no. Alright. What is this angle? Angle PML is 90 degrees. And you must state the reason. The reason why it is 90 degrees is because it is an angle that lies on the diameter and is located on the circumference of the circle. It is 90 degrees, all right? You see that? Now, this is 90 degrees. All right. We know that x here is 33. So you say O, you say LMO or OLM, OML equal 33 degrees. We established that already. Angle OML equals 33 degrees. Right? So you have your 33 here. So guess what now? We can now find this angle. Alright? So angle OMP is what you want. What would angle OMP be? Well, if from here to here is 90, and from here to here is 33, then from here to here it must be 90 minus 33. So angle OMP is 90 minus 33. Angle OMP equals 90 minus 33 equals, so 90 minus 30 is 60, and you drop 3 from 60 is 57. 57 degrees. Alright? So OMP is 57 degrees. This is 57 degrees. Alright. Now the thing is, we have this straight line, 180. So you write that OML is a straight line, so angle is 180. So M, what do they call it again? PML, PMN. Angle PMN would be 180 minus 57. So angle PMN is 180 minus 57 equals, so if we say 180 minus 57 equal 123. So we have 123 degrees here. So PMN is 123 degrees, 123 degrees that we have here. All right. So you see that. Okay, good. What else is happening here now? That is it for the question 9. We'll move on to question 10 next time.